Welcome back, guys. Let's try to solve these tasks now. I'm sure you have already dealt with all the tasks without the help of this lecture. But still, we have to go through these tasks one by one. Let's run this code and import some libraries and create the data frame. So here we have. How many entries we have in our data frame? So we have df as a data frame. So df dot info. Run this cell, and here we have the same output. The next is very simple. Check the head of your data frame, df dot head. Let's run this cell. So here we have the head of our data frame. So notice that we are getting the same values here. So moving forward, you have created a data frame df. Plot C versus D as a scatter plot. Let's plot C versus D first. So we can call df.plot.scatter, and our x he's asking for C, y is D. Let's run this cell. So here we have our scatter plot. We need to play with other parameters. So the first thing is color. So let's set C equal to green and run this cell. So here we have the green color. And the next is the figure size, and this figure size is 10 by 4. Let's run this cell. Here we have the same size of the figure, but one thing is not similar. We need to increase the size of our data points. So let's pass in s equal to, and the size here is 40, and rerun this cell. And here we have the same output. We have the same plot, what he's asking for. Moving forward, create a histogram of the D column. So let's grab the column D, df, D, and call plot.hist and run this cell. So here we have the same histogram. We have the same output. Let's make it a little smaller. And now we can see both our output and the given output on the same screen. So moving forward, the next one is change style sheet and set it to BMH. Add more bins 50 to the above plot. Let's change the style sheet. So we can change the style sheet using plt dot style dot use and set it to BMH and run this cell. And then we can grab df column D again dot plot dot hist and pass in bins equal to 50 and run this cell. So we have the similar plot, but one thing is different here. This one is kind of transparent. We need to pass in alpha as well, 0.5. So let's rerun this cell. So here we have the same output. So moving forward, create a scatter plot for A versus B. How to use the parameter S to indicate the size of the data point based off column D. Let's grab our data frame df, call plot, and we want scatter plot, and then our x is A and our y is B, and he's asking for green color. Let's run this first. So here we have a scatter plot, and now we have to change the size of the bubble based on column D. we know we can pass in s equal to df, grab the column D, and let's run this here. So these bubbles are very small. We need to rescale this, and let's multiply this by 100, and here we have the same plot. Now the bubble size is based on column D. Moving forward, recreate the plot below. This is Hacksmin plot. Let's grab the data frame, call plot, and then Hacksmin. Our X is A, Y is B, and let's run this cell. So here we have our Hacksmin plot. We need to change the grid size to say 25 and run this cell. This grid size looks smaller than 25. Let's pass in 20. So this looks similar. Let's change the color scheme now. So CMap equal to, this one is cool warm. So let's run this cell, and here we have the same plot. We have the similar output. Next one is create a KDE plot of D column. So we need to grab the single column which is D from our data frame and call plot.kde. We can call density here as well. Let's run this cell, and here we have the same output. So we have our kernel density estimation plot. Moving forward, can you increase the line width and make the line style dashed? And don't use .kde. So he doesn't want you to use .kde. So the second option is what we are left with, density. So let's grab the column df D column, call plot.density, and run this cell. So we are getting the KDE plot using density. We need to pass in line width. Let's pass in 4 and see whether it's the same one. So, and then line style, which is dashed. So this looks thicker than this one. Let's pass in 5 here. And here we have the same output again. We have the line width equal to 5 and line style is dashed. Moving forward, create a box plot comprising all columns in the data. And use this color dictionary. Let's copy this one, paste it here, and run this cell. Let's add new column here. Let's call df, and we want plot.boxplot, and color, we want this dictionary, color equal to color, and let's run this cell here. So here we have the same colors for our boxes, medians, whiskers, and caps. So moving forward, create an area plot of all the columns for just the rows up to 30. Let's grab the data frame, call ix on the data frame, and pass in the rows we want up to 30. And let's run this cell first. So here we have 0, 1, 2 up to 30 rows. You can ignore this warning at the moment and call plot. We want area plot, and let's run this cell, and here we have the area plot. One thing you notice that he's plotting from 10 to 20. So instead of up to 30, let's pass in 10 to 20 here to get the same output. If we run this cell, so this is what we are getting, the same output. There is some mistake in this line here, so it should be 10 to 20. One thing you notice that this is alpha effects. So let's pass in alpha equal to 0.5, and here we have the similar plot, but this one is little darker than this one, so maybe the alpha is 4. Now the color looks similar actually. So we have created the same output, which is the same area plot. Moving forward, try to move, so this legend, try to move this legend outside the plot. We can call fig equal to plt dot figure. So I hope you remember this one. Call df dot ix and grab the 10 to 20 rows and then call plot. This is the same thing what we have done here actually. So let's copy this one and paste it here. So what we're doing, df.ix 10 to 20 plot dot area and alpha equal to 0.4, and our axis is fig, and call plt dot legend and loc, which location we want, center left. If you press shift tab, you have upper right, upper left, lower right, and you can pass in numbers as well. So we want center left here. Let's run this cell. So here we have the legend somewhere in the center left. We don't want here, so we want to anchor on the different position. So let's pass in b box and other parameter to anchor and pass in, let's try with 0.5 and 0.5 and see how the things move on. Let's run this cell. So it's moving towards right. So what if we pass in 8? So here we are moving towards the right direction. So let's pass in 1.0, and here we have at the same place. So you can play with these numbers and see how the legend moves. Like if you pass in 0.3, it's moving down. So 0.5. So, and here the legend is at right position. So another thing you notice here, you are getting this line and output, and he's not getting this thing here. And actually he's printing this plot using plt dot show. So let's run this cell, and here we don't have that line anymore. We have the same output now. So this was all about pandas for data visualization, guys. I hope you enjoyed this lecture and learned the way to use pandas built-in capabilities for data visualization. Let's move on to the next lecture, where we will talk about some other useful libraries. See you in the next lecture. Good luck.